I'd like to thank you everyone for taking their time to attend today's webinar. My name is Ronald Wida, a solutions architect at Amazon Web Services. Today, I'm joined by Chuck Price, VP of Professional Services at Logicworks, and Jerry Hagedorn, VP of IT at Spring Venture Group. Now, the word DevOps and container architecture have been thrown around by many people in the industry. In the next hour, we're going to spend some time talking about what DevOps actually mean to an organization, what problem they solve, a look at how to enable such capabilities on AWS. Then we will also follow up with adding containers into that mix, how using container technologies like Docker can further enhance our DevOps tooling. So let's first start off today's topic by looking at DevOps on the AWS Cloud. One of the fundamental benefits of moving to the AWS Cloud is that we are able to quickly spin up resources as we need them, deploying hundreds or even thousands of servers really in minutes. We do this either through the web console, writing a bash scripts, or also making calls to the AWS APIs. As this limitation that typically imposed by the hardware nature of the data centers disappears, the scalability, elasticity, the self-provisioning capabilities through this programmable interface, the cloud really opens up new possibilities that before wasn't possible. Now, these are some of the enablers to DevOps. These days, all types of businesses rely on software, and because of that, when traditionally we think about the separation of IT and business in the organization, both are now so intertwined that any issues IT is facing with delivering technology really directly impacts the business, their ability to deliver value to the customer. Many moons ago, software projects are often seen as a high-risk engagement. They take a long time to complete, but the underlying issues is that most of the people who would benefit from it do not have a clear picture if the final product will solve their problem before the piece of software is developed in the first place. So when we do get to accomplish what we wanted to do, creating a piece of software that fit for function, we would attract many of those users. And here we would have a different kind of problem. How do we keep these services remain available, remain useful as new requirements comes up? So on one hand, many of us are even still struggling with deployment weekends, the sacred ritual that everyone dreads on doing because they rarely go how we want them to. You deploy once, and if it succeeds, don't touch anything. So how do we continuously deliver the same miracle all day, every day? And that's what DevOps promised to solve. Now, DevOps is really the mindset, the people, process, and tools to tackle this very problem. So how can we help our organization to innovate at a faster pace? The good news is these objectives of gaining business agility, decreasing time of value, or decreasing time to value are really not new to us. We tackled many of these very same challenges in the software development world years ago. Through the move from waterfall to agile methodology like Scrum, Kanban, and XP, the DevOps community really seeks to introduce these same patterns, people, process, and tools to the world of software or IT delivery. So the big challenge is how can we move from a long, high-risk, high-gain engagements or delivery to small incremental delivery where business can see quick turnaround to test out different ideas, but at the same time reduce the risk of failure. So as an example, when you release once in a blue moon, releases becomes a big event. It is potentially a new piece of software that no one would recognize and have to relearn. But when you release once a month, a week, in an incremental way, people see incremental features also. So some of the problem that they had a few weeks ago might be alleviated in this release. When you deploy your app once every year, deployment becomes a scary thing. And as we're moving to that shorter cadence, hopefully we are building that muscle, some automation to make deployment simply a business as usual routine. So let's take a deeper look at the ingredients of a common DevOps practice to gain all the benefits we talked about before. We think there are 4 pillars, and we're going to quickly go through some of them today. The first one is the concept of infrastructure as code. Like I mentioned before, We have APIs, CLIs, provisioning templates like Cloud Formation. AWS Cloud has really made infrastructure being as malleable as a piece of software. And because of that, why shouldn't we treat infrastructure any differently to the application we develop or manage? In AWS, every piece of our infrastructure could be or really should be defined in a script or as a Cloud Formation template. This means we can have repeatable process, you can manage changes, you can work in parallel in a team, and also track the change version that has been made to our infrastructure stack. Therefore, you'll be able to get the ability to roll back and roll forward if you wanted to. And I'm not talking about on an application level, I'm talking about on an infrastructure level. You can also potentially explicitly declare dependencies between the apps and the type of infrastructure that they need. Or maybe one piece of infrastructure relies on a different piece of the infrastructure. Adopting the infrastructure as code, as a pattern, also allows us to take on more complex architectural pattern that spans across many servers and networks topology. So microservices, for example, is an architectural pattern that breaks apart application to small modular services where each one of this unit scales and operate independently. Each microservice has its own stack, including potentially its own persistence layer. It then exposes an API with a clear SLA for those who wants to consume it. This pattern buys us a couple of things. One, resiliency, right? As each microservice is independent, it enables us for simpler and more frequent iterative deploys. Cost effectiveness, with the service being so small, we can use many small cost-effective instances than the larger ones. It also gives the dev team freedom to define their own technology stack. One microservice might be using Python, Django. Others might be using Ruby on Rails, C#, Java, Go, whatever the flavor of the month that the team chooses to go with. It also allows the team to drastically introduce new features and perhaps as new microservice. So therefore, you can deploy this new functionality without worrying about breaking core functionality because essentially you're not changing the core functionality by not touching those microservices. And this culture of experimentation really address that innovation part of our objective. So the next pillar that I want to talk about is really having an effective logging and monitoring strategy. It is critical in a DevOps environment to get this right. Log and metric streams from applications and infrastructure should be centrally aggregated to a single pane of glass. This allows the team to understand what really is going on in our apps and infra and able to take preventive actions, remediation, and potentially optimization. So maybe certain instances are over-provisioned. From logs and metrics, you'll be able to take the right measure to address those. Perhaps a specific microservice keeps on falling over and you need to restart once in a while to flush the memory. Whatever that problem may be, the hope is with effective logging and monitoring strategy, you'll be able to proactively react on these issues. Now in AWS, we have CloudWatch and CloudWatch logs. This allows us not to only gain insight to our system, but also with CloudWatch events, we can create alerts based on threshold that you define and trigger automatically a remediation script if we need to. So this enables the dev side of that DevOps component, where now we have tools at our disposal to develop automation scripts as opposed to simply reacting manually when an event or issue occurs. Automate, automate, automate. Lastly, this is the pillar that we're probably going to be spending some time on in this webinar. Continuous delivery pipeline and continuous integration, also known as CI/CD. AWS allows IT teams to rapidly and reliably build, test, and deploy our application in a very automated manner. When a build and deployment process for both application as well as on the infrastructure level is as easy as committing a code or that provisioning script or provisioning template to a code repo like Git, hopefully we'll be able to deliver value to the business faster than ever. Now, the journey to embracing the DevOps mindset can be challenging. As you may guess, the transformation isn't just about the tools, but it's also about how the people and process should evolve along with it. And there are clear benefits on having help from those who have gone through or at least assist other organizations going through the same transformation. So with that, I'm going to introduce you to Logicworks. Logicworks is one of our premier AWS consulting partners who have helped many customers in their cloud transformation journey. I'd like to introduce Chuck Price. Chuck is the VP of Professional Services at Logicworks. Chuck has over 20 years of experience in software development and IT, and was doing agile software development before agile ever existed. Welcome, Chuck.
Thank you, Ron, and welcome everyone. Again, good morning, good afternoon, and good evening. So while we get to the next slide here, let me tell you a little bit about Logicworks. Logicworks is a premier partner in the AWS ecosystem, and our focus as an organization is designing, building, and automating ongoing management of cloud infrastructure. We've been doing this for over 20 years and have migrated a lot of companies to the cloud, managed their workloads, and we focus heavily on DevOps and automation with a dedicated AWS DevOps engineering team. We have a wide range of experience across different business verticals, but particularly customers in risk-averse, compliance-laden industries like healthcare and financial services. So we specialize in HIPAA, PCI, NIST, SOC 2 compliance. Let's dive into some of the details. First up on the agenda, DevOps from the ops side. The focus of the presentation today is to talk about how you build a DevOps practice on AWS. First, we'll give a brief overview of DevOps, then do a deep technical dive into how to build a DevOps practice from the operations side, which, as we'll discuss, is often overlooked in the first stages of agile transformation. Next, we'll look at Docker and then wrap up with an impact on all this automation on your security. After we talk about DevOps from the ops side, we'll introduce Jerry from Spring Venture Group, a customer of Logicworks, who'll pick up the story and talk about DevOps from the dev side, including his deployment pipeline with Docker. But first, a quick poll. Let me open this poll here. So who is currently living the dream of cloud-based DevOps? We'd like to get a sense for who on the call has actually have some experience with DevOps. Is it just you personally? Is it you working with your company? Have you, or do you not have any experience with it at all? So we got the numbers coming in. That's great. Really appreciate you participating. We'll wait just a couple more seconds. It looks like we've got the majority of folks who responded. That's fantastic. So it looks like about half the people on the call actually are doing cloud-based DevOps in some way. Both they and their company are focused on DevOps. And then there's a small group of folks in the middle, and then about 25% of the folks on the call are not doing it at all. So that's fantastic. That group of folks, I think you'll really get a lot of value out of this presentation. So on the next slide, we'll talk about what is DevOps. Ron's already provided a very nice introduction to what DevOps is, essentially the practice of enabling a company to innovate at a higher velocity. As Darwin famously stated, it's not the strongest that survive, but most responsive to change. Change or die, right? All right. But we all know that the dream of DevOps doesn't always meet reality, and this is especially true in the ops portion of DevOps, usually in the first efforts to transform an IT organization. It's really the developers that get most of the focus. Development and deployment tools often get automated, but infrastructure does not, which means that every infrastructure change is time-consuming and risky. Ops is always putting out fires and struggles, and with further compounded when pockets of developers use their favorite and often not well-integrated tools. It's no wonder that more than half of developers still have no access to self-service infrastructure, and more than a third of developers say it takes more than a month to get new infrastructure. So how do we make the ops half of DevOps great? Basically, that's what Logicworks does every day. We're experts at this. We help companies automate operations so that their developer and operations teams stop putting out fires and start delivering better applications. We've done hundreds of these projects, and we find that the key ingredients are, first of all, making it easy for developers to launch approved infrastructure. We're talking about self-service infrastructure, and we're going to get into that and what that means in just a minute. Next, building a self-service catalog means that you can create a clear line of responsibilities between ops and development. No more waiting a month to deploy new infrastructure, and developers can just go and launch a new stack as needed. Great ops also means designing for constant change. As a systems engineer, you simply can't custom build each infrastructure stack for each unique app. It's just not scalable. Instead, you need to start treating infrastructure as code and building templates that deploy infrastructure rather than hand building your instances. All this means you're no longer constantly managing and fixing infrastructure. So with less people in your production environment, you reduce your overall security risk. But we'll talk more about security and why people are important in that still toward the end of this section. So let's take a look at what this might look like. A layered cake diagram here. Any organization that is fully entrenched in DevOps has a stack that may look something like this. You see that the AWS platform is at the bottom in green, which is really the foundation for everything that we do here. In the next layer, you have infrastructure automation. Basically, rather than manually orchestrating different AWS and other services, you build an automation platform that orchestrates those services for you. And there are hundreds of tools you could use in this infrastructure automation layer, but today we're going to talk about mostly AWS Cloud Formation and configuration management. The next layer is your self-service portal, and as we talked about, this is something that your operations team sets up, basically building all the infrastructure templates and security and working in the background so that developers have a simple, easy-to-use interface to launch new infrastructure. In truth, all the work that you do in the infrastructure automation layer is what makes the self-service portal possible. So contained in the blue layers is the information that your operations team would take care of, and at Logicworks, this is really our core competency. So if we look at this layer from a partnership perspective between Spring Venture Group, Logicworks, and Amazon, this may look a bit complex. The Spring Venture Group is a great case study because they've really achieved this DevOps on AWS from infrastructure all the way through to their application. SVG is an innovative health insurance sales company that approached Logicworks last year with the desire to migrate to AWS. They were already proficient at figuring out their application and were using containers on-premise, but they needed help migrating to AWS. As you can see in this diagram, SVG chose to use both AWS and Logicworks to provide the ops side of DevOps, really providing the foundation for their developers to build a fully automated software delivery pipeline without having to worry about infrastructure. We're going to walk through each of these layers one by one, and I'm going to talk about the first three layers before turning it over to Jerry, who will wrap it up with some great info on the application side. So first, AWS platform. As Ron talked about, AWS is quite simply the most robust, mature, and largest IaaS platform in the world. At Logicworks, we've been working with AWS since about 2012 and firmly believe that you can build an equally or even more secure solution on AWS than we could in private data centers. It has dozens of services and also puts a strong emphasis on developing DevOps-friendly services. Basically, they give you all the ingredients for DevOps, but it's your responsibility to coordinate those services in a way that works for your team. For those Lego fans out there, these are the building blocks, the Lego blocks, different sizes and colors and shapes, and becoming a master builder using these Legos to build an automated infrastructure is really the end goal here. So when we look at cloud first versus traditional application development, and we compare what it's like to develop applications in a cloud native, cloud first approach with AWS, leveraging AWS. This is a survey that was done a while ago, but you can see the average time to deploy new applications is 36% faster using AWS. And the number of business apps deployed per year, 120% more almost. The size of your development teams are 22% smaller necessary, so that's a lower investment for faster time to market. And as you can see, unplanned downtime incidents are reduced by 80%, so more stability on the platform as well with a cloud-first approach. So since we talked about AWS, let's jump into the next layer, which is the infrastructure automation. Remember, this is the bread and butter of what your operations team will focus on from a day-to-day basis. Before we get into that, let's do one more survey. Who is currently leveraging infrastructure as code? Who understands really what that means? Who's using it firmly, use it every day, all day, or not really sure what that seems. In fact, the terms sort of seem contradictory. So it looks like about half the folks are learning more now and hope to dig in more this year. So that's great. I think you've come to the right place. All right, why infrastructure automation? In the old way of doing things, we built infrastructure manually. Every environment was a snowflake. That meant if something broke, good luck figuring out which thing went wrong. Also, if you're a system engineer manually building out the environment, there's no good chance that you're going to there's a good chance you may forget how you built something that you built last year or 5 years ago, and it's slow and painful to debug. But when you automate the infrastructure, rather than SSHing into each machine to fix it, you go back into the code, the templates that built that environment, usually an AWS Cloud Formation template, make your updates, rebuild the environment from scratch. It's easy to replicate environments, so you can just tear down the old one, rebuild a new one from the templates without downtime. This is the true meaning of disposable infrastructure or immutable infrastructure, if you've ever heard those terms before. When you build every environment from a template, that means you've finally achieved this holy grail of infrastructure operations, where every environment and every instance is consistent and repeatable. You know exactly how an instance is configured just by looking at the code that built it. It's that powerful. So in the infrastructure automation pipeline, what does that really look like in practice? First, you start off with raw AWS services. This is your EC2 instances, your VPCs. Then your team designs an architecture with these services and any third-party services you use. This is actually the longest stage of the process. This is the time when your security team and your development team should all be involved to produce an MVP cloud. Once you figured out your standard architecture, you can code that architecture into an architecture template in Cloud Formation. Once your infrastructure resources are up, you usually have to do some configuration of the OS. You've probably launched your Cloud Formation template with a base AMI, and usually at this stage, a configuration management tool like AWS OpsWorks or Puppet and Chef, Ansible, etc. will configure your base image. So let's dive deeper into the final two stages of the process, infrastructure templates and configuration management. All right, AWS Cloud Formation. So the infrastructure build-out stage is the most crucial part of the process. And AWS Cloud Formation is simply the best and most incredibly powerful tool to do this. Basically, it's JSON, where you just write JSON and tell AWS what resources to build. It can do things like set up your VPCs and subnets, configure gateways and access points, and all sorts of things that set up the foundation of your infrastructure. For SVG, Logicworks built Cloud Formation templates that included the build-out of AWS EC2 container clusters, service clusters, which orchestrate Docker containers, and Jerry will talk more about this in his presentation. But if you don't already use Cloud Formation, I definitely encourage you to do that. Even if this is the only thing you take away from today's presentation, go out, learn about it, and have your team try it out. The benefit of programmatically building your infrastructure is that, again, you have a consistent, stable, repeatable way to build out infrastructure that has all of your security standards built in, rather than having to manually rebuild each time a configuration changes. So the next stage is configuration management. The purpose of configuration management is to get your instances ready to receive your application code. This means configuring host names, binding instances to central auth, and installing various packages. At Logicworks, we have a central Puppet module that has basic policies that our clients will use for most of their environment. Together, AWS Cloud Formation and Configuration Management are the one-two punch that gets your infrastructure ready to receive code. When you configure your instances with a tool like Puppet or Chef, and then use a code repo like Git to version control your Puppet and Chef scripts, you're essentially treating the configuration or infrastructure like software. Software that can be easily modified, replicated, rolled back, versioned. Imagine that rather than having to manually install packages or remember to update packages, you can write code to install those packages once in a central location and then have 100% certainty that all your instances will meet that new configuration when checked back into Puppet. Incredibly powerful. Finally, in the case of Spring Venture Group, they had to maintain HIPAA compliance. So you'll see that a lot of the things that Puppet does, like configuring log shipping and monitoring software, are essential components of meeting HIPAA compliance. Logicworks infrastructure automation means that SVG has 100% certainty that all their instances meet HIPAA standards. But now all that automation is in place, the next step is letting developers push the button to build out new environments. That means we're to the self-service portal. So the AWS Service Catalog is a service that allows us to create a catalog of AWS Cloud Formation templates that are approved for use on AWS. So in the case of SVG, Logicworks built out the Cloud Formation templates, put them in the Service Catalog, and now SVG developers can launch AWS environments that are configured to their exact specifications on a repeatable fashion, including their EC2 container service, which are ready for their containers. So what's the impact on security? While we're wrapping up this section, let's look quickly at the impact of infrastructure automation in the Service Catalog on security. As you can see, if your developers and operations folks only launched approved AWS Cloud Formation templates, then you have a carefully controlled build-out process. Your security team gets involved in creating the templates and building in crucial configurations and templates so that no infrastructure components ever get launched without MFA or encryption, for example. Your operations team is no longer handcrafting each environment, testing environments, mirror production environments, and there is consistency. Second, you have a controlled update process. Rather than doing one-off fixes and constantly firefighting, your operations team is changing code, not servers. That means every change in your environment is documented. If you work in a company with compliance requirements, you know how valuable it is to be able to show an auditor that no one makes direct changes to a production environment and all changes are carefully documented and version controlled. Finally, this gives you peace of mind that your developers and operations aren't touching your production infrastructure, so you have less of a human risk of human error, but humans are still important. So the key takeaways to wrap it up: remember that building a fully automated cloud environment is complex, but it is critical, especially if you have a complex set of applications, even more so the more complex your application. Self-service infrastructure enabled by infrastructure automation is the foundation for DevOps. Developing your CI/CD pipeline is important, but remember the impact on your business of automating code delivery is severely hampered if it still takes a month to build new infrastructure. And of course, all this seems a little bit too complex, and if you'd rather just focus on your application development, you can talk to Logicworks to support your efforts. Next, Ron, I'm going to turn it over to you to introduce Jerry to get into the application and CI/CD pipeline portion of the presentation.
Thanks. Thanks, Chuck. Thanks for taking us through the core parts of DevOps. And for this part of the webinar, I would like to welcome Jerry Hagedorn. He is the VP of Information Technology at Spring Venture Group. He has 21 years of software development experience, as well as architecture and leadership under his belt. He came from Department of Agriculture, driving change for 10 years, then joined Spring Venture Group in January 2016. Welcome, Jerry.
Thank you, Ron. So you just heard Chuck from Logicworks talk through the three operational layers up through the Service Catalog. I'm going to talk about the deployment automation layer, as well as how SVG leverages the Service Catalog to create a seamless integration between our two DevOps stacks. So a little bit about Spring Venture Group. So SVG is a group of sales center-based insurance brokerages that all work in the senior insurance space. We've been around for about 8 years. We have an awesome sales team that help our clients navigate through the complexities of Medicare during a significant transition in their lives. About 3 years ago, SVG started making a significant investment in developing IT systems to differentiate itself in the marketplace. Our distribution platform has had a major impact in allowing our agents to better help our clients. SVG has an amazing culture, and we've been recognized by Ingram's as the best company to work for in the insurance space in 2016, and just last week Ingram's announced that we won that same award for 2017. All of this has led to a significant growth in both revenue and staff size. In 2016 we had 150% revenue growth, and in the last 18 months the company overall and the IT staff has tripled. So what are we going to talk through in this last third of the presentation? So we'll go over Spring Venture Group's technology goals. We'll talk about why we chose Docker. We'll go briefly over our deployment pipeline. We'll talk through Docker orchestration and security. And then we'll wrap up with talking about how combining infrastructure automation and deployment automation leads to efficient developers, which help us drive our mission. So our goals. So when I arrived in January of last year, we had a great group of developers here at Spring Venture Group and had about 25 systems and services running on a very brittle on-premise infrastructure. We had stability problems that impacted our business, and we had to have heroic efforts to go through and minimize the impact of those issues on our business. So the first thing that we wanted to make sure that we had was a stable, solid infrastructure that was simple for us to maintain, as well as allowing us to grow as our business grew. The second thing is we wanted to focus on development and not infrastructure. So we wanted to focus our limited IT resources on implementing those business solutions that help differentiate ourselves in the marketplace and find a partner to help us focus on AWS infrastructure. Then lastly, as part of our rollout and our migration to AWS, we wanted to adopt a DevOps mindset. So we wanted to implement development operations and automation from the infrastructure all the way through code deployments. We wanted to do this to make things easier for the developers to do their job, as well as increase the quality and stability of our business solutions by implementing things like automated testing and consistent deployments. And finally, we wanted to focus on compliance. So in a world of ever-increasing security threats, reactive policy and procedure-based compliance is just not a viable option. So we wanted to make sure that we had an infrastructure that was focused on proactive compliance. So our solution. So first we chose Docker and ECS, which for us was the natural fit as we were implementing a service-oriented architecture running LXC containers on-premise. We also chose Logicworks as our managed hosting provider because they had expertise and competencies in both healthcare and DevOps. And they also had experience implementing Docker. And then finally, we chose Amazon Web Service for all of this to run on for a few different reasons. So first of all, AWS has a long history for support on open source products like the ones we use. They had a breadth of capabilities that existed at that point and a history of delivering increasing capabilities over time. And they have a very mature and stable platform on which our business can grow. So with Docker, what do you get? So the first thing is you build that Docker container once, or you build that Docker image, you can then use that to pick it up and run it anywhere. Because the application and the OS dependencies are all packaged together in that Docker container, you don't have to worry about missing dependencies and packages as you pick that solution up and run it in one cluster or another. Because of the sandboxing with Docker, it isolates your software, and it also provides isolation for code failures. And then finally, Docker makes it easier to automate testing, integration, and packaging. So as technologists, we often get lost in technologies. I talk to my folks about making sure that we focus on the why, so we can understand really what we're trying to accomplish with what they're building. So Solomon, the father of Docker at DockerCon 14, talked about the essence of Docker and how the essence of Docker is really about the standardization that comes from getting people to agree on things and not the technologies. So some basic terminology around Docker. So you'll hear the term Docker Hub, which you can think of as a GitHub, or you'll also hear it referred to as a repository for your Docker images. The Docker file is the text file that contains the commands to build out those Docker images. So Chuck talked about Cloud Formation in his presentation, and so the Docker file in the Docker world is that Cloud Formation, so that those are synonymous. Finally, once you've built that Docker image, you think of the Docker image as that executable. That's what you put in that repository. Then when you go to actually run copies of that, that's where those images get spun up and turned into the actual containers at runtime. All that then is managed by your Docker daemon, which basically builds them, runs and distributes those containers for you. So our deployment pipeline. So Chuck talked earlier about the AWS Service Catalog, and in the event that we need to stand up a new cluster, which we do on occasion, then that would be the first step of this process. We would either through API or through the console use the Service Catalog to stand up a new ECS cluster. A lot of times though, we're just deploying or redeploying a container into an existing cluster. In that case, we would start with checking our software into our source repository. Once we do that, that would be merged into a branch, would kick off a Jenkins build. The application artifacts would then be built, test cases would be executed to ensure the quality of that application artifact. Once we had validated the quality of that application artifact, we would then go forward with steps 3 and 4, which would we pull down the base image, Docker image, and build the new Docker image. At that point, we would then push that Docker image up into our Docker repository, which is step 5 there. We might execute any additional provisioning activities such as creation of Route 53 entries, those sorts of things. We would place that Docker image in the AWS EC2 container service or ECS, and then we would start that service. So, and as Chuck talked about earlier, Service Catalog provides Spring Venture Group, from a client perspective, a consistent ECS-ready environment. All the controls and everything that Logicworks has built in from an infrastructure standpoint to ensure HIPAA compliance is all there. We don't have to worry about that. We just execute a command and we get back infrastructure that we know is consistent. And there's no delays or friction between the operations DevOps stack and our development DevOps stack. So some key tips for adopting Docker. So automate, automate, automate. So when you're implementing Docker, the scale very quickly grows with you. So when we initially deployed mid-year last year, we had about 25 Docker containers. We've about tripled that number really within less than a year. So you really need to focus on getting that continuous integration, continuous deployment automation in place, at least a solid version of that, so that the environment doesn't get away from you. Invest early in service discovery solutions. So this was one of the things that we thought we could get away with without implementing initially. Sort of realized after the fact that this was something that we wanted in place, and we're now going back and rolling this out in our infrastructure. Embracing external configuration isn't necessarily specific to Docker, but anytime you can take functionality and push it out, or an ability to configure or make changes without redeploying an app, that's always a good thing. The next bullet point on health checks is really, from my perspective, the biggest gain that we got from implementing Docker and ECS. So when we implemented the Docker health checks, we implemented them from looking at the perspective of, is the application able to provide the business value that it was intended to provide? And we built our health checks in that manner. And so then when a health check fails, we then built a wrapper around that we can then look at the fact that that failed and take the appropriate action. So for example, we could terminate that Docker container and then have ECS stand up a new Docker container in its place. And that last part would happen automatically. And just by implementing that one item, we've seen an incredible increase in the stability of our infrastructure from our business users' perspective, right? So weird things that might have created a situation in an application where an application became unhealthy, those things self-heal at this point, and we don't have to, they don't impact the business, and they don't impact a developer or an operations person time to go track it down. Lastly, when we kicked this process off a year and a half ago, only the classic load balancers were in place. And at this point, with application load balancers, we're beginning to roll those out, so my recommendation would be to head down that route at this point. So Docker security. With Docker security, the first thing is that you're going to gain is application segregation. So what that allows you to do is minimize the number of OS features that exist in each of those Docker containers, which thereby reduces the potential attack surfaces of things that can be taken advantage of by a would-be hacker. The next is the fact that Docker environments tend to be very transient. So you're standing up a Docker container that's running an application, and then periodically you're rebuilding and creating new versions of those services in a microservices or a SOA environment. So because that, your Docker containers tend not to be long-lived, and in a lot of cases, security vulnerabilities come from the fact that you have environments that live for long periods of time and don't get patched correctly or can't be patched, and vulnerabilities then come to light. As was talked about earlier, these Docker containers are immutable. Just like with the Cloud Formation templates, the Docker containers, you're going to build them, you're going to run and execute tests and ensure that your application works with the Docker container that way, and then that's what's going to run in your production environment until you replace it with a new version of that Docker container. Docker and ECS provide an ability for resource isolation so that you can limit the amount of memory or CPU any given Docker container would have to leverage. Having said that, Docker does leverage a shared kernel on that host. So you just need to take that into account as you're thinking about the security of your applications. And so if you have services or applications that have significantly different security requirements, you might want to think about spreading those apart into different clusters or tagging them so they run in different instances, those sorts of things. So Amazon EC2 Container Service, or ECS, is a highly scalable, highly performant container management service. It's lightweight. From our perspective, it eliminates the needs to install and operate the cluster and the management infrastructure, because AWS manages that for us. And ECS has no additional charge. You just pay for the EC2 instance that run your Docker containers. So Docker orchestration, there's many different types of options out there for Docker orchestration. We chose Amazon ECS for our orchestration, and we made a conscious decision when we moved towards AWS. We made an investment in it, and we wanted to make sure we leverage AWS native solutions wherever possible. Again, back to that, we wanted to focus on the development, not the operations. So ECS provided a stable, maintenance-covered solution for us, and so in addition, it met all of our environment needs. From a ECS Docker perspective, we saw a significant improvement in the stability of our environment when disposing of containers through these health checks. And in addition to that, Logicworks was there to support and manage our infrastructure. So from our perspective, we were able to leverage Docker without any worry about managing the orchestration layers. So as we talked about earlier, we chose to work with Logicworks to expedite our migration to AWS. So we sat down originally with Logicworks and talked through our requirements, talked about what we were doing, how our systems were built. Based upon that, Logicworks put together an architecture that ensured our HIPAA requirements were being met. They then took those requirements, built out the infrastructure using their DevOps stack process, and then stood all that environment up. We then took that environment and started building our continuous integration, continuous deployment automation on top of that. One of the things that as we continue to grow as an organization, we are starting to look at doing more and more customer-facing integration. And so as part of that, we knew we were going to need more and more 24/7 by 365 support in case there was an issue with one of our systems. And I didn't want to go out and hire a set of operations staff to manage a NOC 24/7. So we got that out of the box with our relationship with Logicworks. As we talked about with the service catalog, they created that service catalog, allowing us to have a one-click or API-based ability to stand up infrastructure. Additionally, we continue to use Logicworks ongoing for their expertise. So as we have new business solutions that we need to deliver that may require leveraging new AWS services, we sit down with them, talk about how we best do that to make sure that we optimize the investment that we have with AWS. So to kind of begin to wrap up and talk about the results of our project overall, so we started our migration effort in February of 2016 of last year. The whole migration took about 5 months. Most of that time was us working through building out our continuous integration and continuous deployment stack and really refining that over time. Additionally, one of the big benefits that we got was building out a separate testing region, which we didn't have in our on-premise environment, which has helped us increase the quality of our solutions as we deliver them to production. So we delivered the last of the 3 phases of our migration in July of last year. We did that with a minimal business operational impact. We delivered several key business deployments in that 5-month period of time, and we nearly doubled the number of users that our systems were supporting. So some key takeaways for your team from my perspective or kind of a client perspective is, we talked about before, automation is the key to doing DevOps, and specifically with looking at things like SOA microservices and doing that with a DevOps environment. You need that to really ensure the efficiencies of your developers. On health checks, I'd really encourage you to think through what you're doing with those health checks and make sure that they're as robust as you can so that you get the most stability out of your platform. And finally, the last point is partnerships are key. There's no way we could have gotten that AWS migration done in the 5-month time frame with the quality of the solution that got delivered without our partners at AWS and Logicworks. So finally, we are looking for a great DevOps engineer to help us manage our and grow our continuous integration, continuous deployment environment and support us with application monitoring. So if you know somebody, there's a link to our career site, and we'd be happy to have them apply. With that, Ron, I'm going to hand things back over to you for Q&A.
Jerry, thank you so much for taking us through the value of containerized architecture in a DevOps environment. So I hope the content has been useful for everyone. We've got 10 minutes left to the hour. We covered the concept of DevOps in general. The goal, just to quickly recap, is to increase our pace of innovation. We talk about the 4 pillars: infra as code, microservices, login monitoring, CI/CD. Chuck took us through the value of automation, configuration management, and also a build pipeline. Jerry then added on, taking us through the value of containerized architecture using Docker and orchestrating that using Amazon ECS. So we have quite a few questions here, and we'll go through it as much as possible. If we couldn't get to your questions today, we will try and follow up as best as we can. I also would like to welcome Phil Christensen. He is a senior solutions architect from Logicworks who will be helping us with some of these questions. So let's just go through it. So the first question that we have, maybe for Jerry. Jerry, would you mind talking through about the Docker image a little bit more in a simplistic way? What is it? What is it for? What do you do with the Docker image?
Sure. So if you really think about a Docker image, it's really the executable. So if you think of like something as simple as like Word or an application, it's that executable. And that Docker image is going to encapsulate whatever the application is along with the infrastructure. So it's that application along with the OS, all of that stuff packaged up in one thing so that you can pick it up and run it anywhere that you want. So hopefully that provides a little bit of clarity.
Oh, absolutely. I think essentially it's a container template, right? It has the components of the operating system, the apps, and all the configuration that you might choose to include as part of the image, and therefore you can kind of spun up different instances based on those images. Another question probably related to that, is Docker free? Is there a cost of using Docker as a technology?
Docker is an open source solution, and again, we're leveraging ECS, which is AWS's version of Docker, and that, again, as we talked about in the presentation, is also free. You just pay for the actual runtime execution of your EC2 containers.
Awesome. We have a question around Amazon EC2 Container Service, or ECS. What is an ECS cluster? And maybe I'll take a quick stab on that, and if Jerry or Phil would like to jump in, please do so. Essentially, EC2 Container Service is our Docker container orchestration service. So when it comes to containers, you want to have a orchestrator that spins up those Docker instances, those container instances, to serve requests. Maybe they are websites, maybe they are web services, and manage the life cycle of that. When do you want to launch it? When do you want to terminate it? And ECS cluster is really the pool of EC2 instances, or the pool of virtual machine instances where you're hosting this Docker container. So think of it as another layer of a virtualization. You may have, and obviously Docker container isn't a virtualization technology, but you can think of it as that. You may have 5 Docker instances running on a single ECS instance, which is a part of a bigger cluster. Jerry or Phil, would you like to add anything on top of that around ECS cluster?
I would just add the other additional thing that I think is really important about understanding with an ECS cluster is that that's how you are going to achieve high availability. We talk a lot on AWS about availability zones and ensuring if you're trying to have that level of high availability, ensuring that you always are across multiple availability zones. If you want to have that same kind of redundancy on your Docker cluster, you'll want to do the same thing, only this time you'll want to have a Docker container in 2 places on 2 different availability zones. And the way to do that is to have 2 EC2 instances and ECS will help you manage that and ensure that those containers are across AZs.
That's a really good point. The next question, it sounds like we have a lot of container-related question, which is kind of somewhat expected, I guess. So question to Jerry. Jerry, you're very popular today. Did you build your own application load balancing layer to manage the microservices deployed as containers? Did you use the AWS tooling, or did you use any other open source framework?
For the most part, we use the classic load balancers as we talked about, and then going forward, we're looking at using the classic load balancers along with some other technologies to sort of combine together for that load balancing.
And I think for those who are not familiar with ECS, and if you happen to use ECS, application load balancer integrate really nicely with Amazon EC2 Container Services. It does the port forwarding for you. It does the service discovery through DNS, through URLs. So that is something that I would suggest for you to look at as well. Let's go through a couple here. What about on security? We touch on security, and there's a question here around automating security testing as part of the deployment process, whether it be a static analysis or dynamic analysis. Phil, Jerry, do you have any opinions on that?
So, I mean, I'll jump in real quick, Phil, and then you can add to it. So, absolutely, I mean, part of your continuous integration pipeline should be various testing tools and looking at static code analysis and other things from that automated process should be one of the things that you should be building into your CI stack.
And the reason I was accidentally jumping in there was because a similar question came up recently as well related to unit testing with regards to your development pipeline as far as how this fits into the Docker integration as well. And I think this is true for both, whether you're doing unit tests, something as simple as linting, or actual security analysis, is that this is an unusual scenario where I think you're actually going to do the build first and then analyze the build. So you're going to create your Docker container and then run your unit tests from within that Docker container, run your security tests from within that container. And so there's a set of ways that you can handle that so that you also achieve some of the minimum deployment things that Jerry was talking about, as in having a base image that is your core application, and then having an image that extends from that includes your unit tests and the other security related or testing related items that you might need to run as part of your deployment pipeline.
Fantastic. I think we captured some other questions as well with that answer. So we have a lot of things to go through, and unfortunately we only have 2 minutes left, so I'm gonna perhaps save it for follow-ups. The team's gonna try and work hard as much as possible to follow up with every single one of the questions, but we do have lots of questions to go through, so I apologize if we cannot go through all of them today. So I wanna share with everyone here a couple of resources that you might want to look at. There's a couple of white paper by our friends at Logicworks, a couple of reference architectures, as well as a white paper from AWS around using AWS ECS alongside Docker containers, as well as building up your own CI/CD pipeline on AWS. With that, I thank you so much for your time today, and I look forward to seeing you on the next webinar.